All right, hello everyone, welcome, welcome. Let's go ahead and get started for today. I'm going to take a few minutes up at the top just to kind of refresh your memory on how all this exam stuff works, give you a few kind of tips and pointers from my perspective, and then the rest of the time will be open for you to ask questions, go through practice problems. I'm hoping to do a lot of practice problems today. That's kind of my goal. So I hope you all have some ideas of some problems you'd like to see me walk through. But first, let's just kind of review what to expect coming up on the exam. It's this Thursday. It is in the evening. And the room you went to last time should be the same room that you go to this time. So there should not be any difference in what room you go to. It should be the exact same room you went to take the prior exam. So double check that information. Make sure you know where you're going before the exam starts this Thursday. You can bring a sheet of paper. So just like the last exam, you're welcome to bring a sheet of paper. You can put whatever you want on there, front and back. It can be typed, it can be handwritten. Just remember the rules about that sheet of paper being one sheet of paper, right? One normal size sheet of paper, either notebook paper or printer paper. And no use of any outside tools to view what the contents of that paper are. Should be able to look at it and see exactly what's on that paper just with my admittedly bad eyesight. So that all is the stuff that really hasn't changed from the last exam. Now let's talk about the stuff that will be different for this exam, specifically the content. The content that's going to be on this exam. I'm going to repeat for the millionth time, at least it feels like the millionth time, the Module 7 stuff that we did last week, not on this exam. Will not be on this exam. No constructors, no instance variables, no creating instances, none of that stuff. Not going to be on this exam. That will be on exam 3, and we will resume our conversation of talking about objects and how to use them next week after we get through this exam. So what's going to be on this exam? We're going to cover modules 4, 5, and 6. So module 4 was about APIs. Specifically, we've talked about how we've seen a few APIs already. The scanner API was one example we talked about. Standard draw API is another one that we talked about, how to draw stuff on the screen. I want you all to know that if you need to use the standard draw stuff on the exam to draw something for a particular problem, I will tell you that there is a method called circle, and that method asks for the XY coordinates of the center and the radius. I will give you that information. You do not need to memorize all of the stuff that is in standard draw. You do not need to put all of the different standard draw stuff on your sheets. That is not a good use of your sheet. If you need methods from standard draw on the exam, I will tell them to you. That's actually kind of the skill that we're trying to train you for that particular module. If I tell you that a method exists and tell you what the inputs are and what it does, can you use it properly? That's kind of the whole point of module 4. So don't worry about having to remember every single thing that you can draw and how it all works. If you need it, I will give it to you. It will be given to you on the exam. Module 5 was about methods. Again, I want to reiterate that all of the methods that you see on this exam will be static methods. A lot of time that's going to be told to you directly, just to avoid any confusion about what we've talked about in Module 5 and then what we recently talked about in Module 7. There's a big difference between the two, but that difference doesn't matter for this exam. We're going to be doing things statically, and a lot of times that's going to be given to you directly on the problem as well. And then for Module 6, recursion, it is going to be on the exam. This is usually what people are most nervous about on this exam. Recursion, I understand, is not the most straightforward topic, not the easiest to understand topic. But just be aware of the fact that even though recursion is on this exam, it is one of 3 topics that we have covered. Sometimes I see students try to force recursion into everything on this exam, and that's not necessary. Yes, there will be problems on the exam that say you have to use recursion to do this. There will be plenty of other problems that don't say that, and you don't have to use recursion if that's not a specific requirement of the problem. So, I mean, you can. That is your choice, right? But a lot of times students will overcomplicate some of the problems on the exam by trying to force recursion into every single answer. Read the problem carefully. If you aren't required to use recursion, personally, I wouldn't. That's just me. But it's up to you to make that decision. on the exam. So I just want to make sure you're aware of that as the exam comes up on Thursday. Before we hop into practice problems, just want to pause here for a moment and see if anybody has any questions about the logistics, where to go, what can be on the cheat sheet, stuff like that. What's going to be on the exam. The next step is to switch over and hopefully do some coding exercises. But does anybody have any questions for me before we hop into that stuff? Okay, and so then just like the previous exam, I hope you're all aware of the fact that there are resources on Canvas available for you to assist you with studying for this exam. Just like the last exam, there's a practice quiz that includes a bunch of fill in the blank, multiple choice, true-false style questions. And then just like before, there's also a second resource for coding style questions. In fact, I already have that coding repository opened up. In Eclipse, you can see that there's a whole bunch of code reading problems and a whole bunch of code writing problems. This is kind of what I'm hoping we'll focus on for the rest of the time today. So yeah, at this point in time, I'm going to open up the floor and see if anybody has any questions. You're not limited to these things. If you want to ask me questions about stuff on the practice quiz, I'd be happy to talk about that. If nobody gives me anything, then I'm probably just going to start picking code writing problems at random and working them through in class. But I would love to hear from you all first. Is there any particular problems that you would like to talk about, see me walk through? Yes? Question 1 on the code writing. All right, let's do it. All right, so we're diving right into recursion. I can see from the name of this method, it says that we are going to, okay, so this is one of the image drawing recursive methods. Not a bad place to start. It actually says that our task is to complete the method to draw an image that looks similar to this. So we need to go figure out and see what that looks like real quick. Image number 1 is right here. There it is. Can I zoom in on this a little bit? So this is the image that we are tasked with replicating for this particular problem. And if you're faced with a drawing problem, I think the first thing to decide is, is this something that needs to be done recursively or not? Sometimes the problem will tell you this is going to be done recursively. I think that's what this one does. I think it says you have to do this recursively. It's very possible that I ask you to draw stuff without using recursion. So please read the problem very carefully. Make sure you first understand what kind of problem it is that you're trying to solve. If it is a recursive problem, then the task is to identify where the patterns are, where the patterns appear. So I can see that there's a big square here in the middle. And from there, it looks like I go up to the top left, the top right, bottom left, and bottom right, and I draw squares. And then from there, it looks like I go to the top left, top right. What is this problem an example of? There's a type of recursive problem that this fits in? Yeah. Divide and conquer, exactly right. This fits into the category of recursive problems that we described as divide and conquer problems. And the nice thing about divide and conquer problems is that they'll follow a similar kind of approach. I expect to see one recursive call in my solution for each of these 4 directions. You would have seen the same thing in the circles upon circles example from Studio as one that comes to my head. Max path length from the homework assignment that's due this week is also an example of a divide and conquer problem that will have multiple recursive calls, one for each direction you need to look in. But for this particular problem, we need to figure out how to get from this center point up to this center point. Let's switch back to the code now and see what we can do here. So yes, it has to use recursion. Here we're given the center point and the half length of the square. I think our first task is to simply draw that square using the given values. Because this is recursive, I know that there are going to be at least 2 options going forward, right? One of the options is going to be to do more recursion, and the other option is called what? In a recursive method, I either do more recursion or I've hit what? Yeah, the base case. The base case. So we need to identify what the base case is. I actually like starting with the base case. I think starting with the base case first makes sense. we're really asking ourselves, when do we stop? And for these driving kinds of problems, if we refer back to the image, it's almost always going to be a stopping condition of when we're small, right? When we're too small to keep going. So, you know, how small is too small? I mean, it's somewhat arbitrary. If the problem doesn't tell you, then you're welcome to come up with your own arbitrary stopping point. In this case, you know, if the half width is less than, I'm sorry, if it, well, it's kind of an interesting thing that I did here, right? I could actually write this in two different ways. I could say, you know, if the half width is big enough, keep going, or I could write it the opposite way, right? I could say if the half width is too small, then stop. And actually, it's called half length, not width. That's why Eclipse is mad at me. There we go. So if the half length is big enough, I wish to keep going, and this is where my 4 recursive calls are going to go. One for each of the 4 directions that we need to move in. We just need to figure out how to get there. So if I look at this image here, if this is my starting point, that's 1 half width. Feels like it's 2 half widths in both directions that my center point is moving. So from here to here, there's 1 half width, there's 2 half widths, there's 1 half width, there's 2 half widths in both the x and the y direction. So if I wish to make the recursive call going up and to the left, I'll say recursive carpet, and then I need to adjust the center point for x by 2 half widths to the left, so it would be subtracting 2 half widths. So it would be the current x center point minus 2 times half length. The y coordinate would be similar, except I'm moving up. So my current y coordinate is here, and I'm going to be moving up, so I need to add 2 half widths instead of subtracting. 2 times half. I keep saying half width when the variable is called half length. They're squares, so I guess it's kind of the same thing. And then we need to decide how this factor is changing. So the size is going to get, I keep clicking the wrong tab. The size is going to get smaller. How much smaller is this square than this square? I feel like that one is kind of a judgment call. It looks like it's divided by 3 maybe, or 2. I mean, we can guess and check. On the exam, I know you can't guess and check, which is why I think it's very important to say that if you're off by 1 or off by a little bit, that's not what I care about. I care about, do you understand the structure of this problem? Do you understand how to code a divide and conquer problem? That is what I don't know why I put brackets in there. It's just my brain being on autopilot. I need to put a semicolon there, not brackets. All right, let's try this. We haven't done 4 recursive calls yet. We've actually only done 1, but hopefully we can at least see that 1 in action before we, whoops, do I have an error? I do have an error somewhere. Why are you unhappy at me currently? Oh, it's this variable name is not correct. It should be y center. That's the problem. All right, let's try that again. Okay, so it looks like a couple issues here, right? One, I kind of overshot. Looks like I overshot a little bit with my distance, or maybe I didn't, actually. I'm not so sure. Maybe I need to use a filled square here. I feel like that's a little nitpicky, but whatever. It did go up and to the left. It looked like it went too far, though, to me. Too far. Or this is too big? Or actually, let me see for a second. Maybe what I need to do is move this drawing spot inside of the if statement. Does that help me at all? No, it's the exact same thing. It's kind of what I thought. Let me think for a second. Let's just be off. Maybe it's just, maybe I don't need the 2x. Maybe I just need the 1. Oh, okay. I mean, you can definitely see the recursive pattern this way, but I think it was more correct before. with the 2x in there. I think I was more correct the first time. Let's continue on with our 3 remaining recursive calls, since they'll all be a variation of this one. It's just a matter of figuring out whether I'm adding or subtracting to my x and y coordinates. So if the next one I want to do is this top right one, then that's going to be adding to the x and adding to the y. So I need to flip this sign. For the bottom left coordinate, that would be subtracting from x and subtracting from y. So I need to have one that subtracts from x and subtracts from y. There it is. And then for the bottom right corner, it would be adding to x and subtracting from y. So flip this to be a plus sign. Let's see where we're at here. Oh, well, clearly I'm a little off on something, but it's close. What did I must have made a mistake in here somewhere. I just don't see it. Oh, I've got one too many pluses here, that's for sure. Plus plus would be upper right. This should be a minus. Should be a minus. That was definitely a mistake. Whoa, okay. You can see we're moving in the right direction if you look at this image and this image. I can see that I'm very close. What are the differences? I think some of the differences are my stopping condition. I think maybe the half length is actually divided by 3 and not 2. I actually would accept this as an answer to this problem. That actually looks similar-ish. This first square looks too big. I kind of want to cut that in half as well for some reason. I don't know. This solution, I think, is very much there. I know it doesn't look exactly like this image. I want to make it clear, though, that I'm not looking for perfection on these problems. What am I looking for on these recursive drawing problems? I'm looking to see that you stop when the given size gets below a certain point. I'm looking that you have your divide and conquer problems. These numbers here, the multiplying by 2 and dividing by 3, I'm not going to grade those. I'm not going to take points off for those if they're a little off. I want to make that absolutely clear. In order to get those 100% proper, you would need like a ruler, right, to measure those things, and that's just not something that I'm expecting you to do on the exam. So yeah, are there any questions about my solution to this problem? I think I wish I could start this a little bit smaller, maybe like that. Maybe I just need to start it out a little bit. Oh, that looks so much better, actually. Yeah, that looks much more like the reference image. I think the original square was just too big. This looks much more like the given reference image. In fact, looks like it stops a little too soon. Maybe we need to go a little deeper. Oh, beautiful. Yeah. There we go. That looks very much like the given reference image. That's good. That's a good solution. Any questions on this problem? Or divide and conquer problems in general? Recursive? Yes?
Yeah, what was the second to last thing you changed before you made the end case way smaller?
So I made this smaller, and then I had a typo in one of these.
Oh, you made the half length smaller?
I did make this I made this initial half length smaller, yes. Okay. That was actually probably the biggest problem with this. It was set to be 0.25, and it was too big, so I cut it in half, roughly, to 1.25. I wouldn't expect you to know that in the middle of an exam, though, right? Like, that's not a reasonable thing for me to expect you to compute, which is why these problems, again, largely graded on structure. If you have 4 recursive calls here moving in the right 4 directions, that's worth the big chunk of points on problems like this. Any other questions on this one before we attempt another problem? Does anybody have another problem they'd like for me to start coding up? Or should I just pick one? Yeah. Problem 6. Okay. Yeah, so this is a tricky one. You've actually picked out what I would say is probably one of the trickiest problems that I've given to you, but it's definitely doable. This is definitely a doable problem. The idea here is that I'm giving you this method. I've given you this code, and we can see it uses a loop. It's using a loop. So this is using iteration. The problem starts down here. It wants you to redo this operation, but using recursion instead. So we want to use recursion to do exactly the same thing as what this method does. And actually, this method is computing square roots. So if I plug in 2 for the square, if I plug in 4 for the parameter, I should get 2 back. It's computing square roots. Using a method called the Babylonian method. It's actually a very, 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 very famous method. It's got its own Wikipedia page. If you're interested in reading more about it, it's actually pretty interesting, at least in my opinion. I'd encourage you to check it out. What I want you to pay attention to is all of the parts that I see up here are going to show up down here. They're going to show up down here. In our recursive method, it's just a matter of figuring out where they need to go. Recursion and iteration are both ways of achieving repetition. So we're going to use our recursive method to try and replicate the repetition that's happening here inside of this. And so with that in mind, I can look at this condition here and say, well, that's probably what my base case is going to be. That's what my base case is going to be, is based on this equation here. Since this is what tells this loop to stop, some version of this is going to be what tells my recursive version to stop as well. And so at this point in time, it might be tempting to come down here and try to do something like that, right? Oops, that's from the last problem. I meant to copy this. Say something like, if this equation is less than 0.1, then we're done. We know what our answer is, right? Our answer is going to be this, right? If this fails and the loop is over, then this is what our answer is. However, you'll see that we have a problem. These aren't defined. I don't have these. I don't have these variables. And so you may be tempted to define them. You may notice these statements up here and say, okay, I need to declare these variables and use them and copy those down in. But actually, that's kind of problematic as well. This is going to be an issue too. We actually need to do something else here. Can anybody see what we need to insert into our recursion to make it easier for us to accomplish this? Starts with an H. We need a helper. We definitely need a helper. There are 2 reasons why we need a helper method. 2 reasons why we might consider using a helper method. Does anybody know one of the 2 reasons? Yeah. So we can keep track of additional values. In this particular case, the old value of x and the new value of x, we wish to keep track of those values. So having additional parameters would help us do that. We need a helper method in order to pull that off. What's the other reason why we use helper methods? I actually think this reason's valid here too. If we look at this one, this stuff repeats, but this stuff doesn't. So that's kind of the other use of helper methods when using recursion. The stuff that doesn't repeat can go in the non-helper method, and the stuff that does repeat, this is going to be our recursive method here. So we need a helper method. We need these additional parameters in our helper method to, compute this problem properly. So let's go ahead and include it. Static double square root helper. I'll say double x old, double x new. And now our base case, right? If I move it down here to this method, it does make sense. I have these variables. I can do this. So it doesn't belong up here. Instead, what goes up here, I need to kick off the repetition. I need to kick off the recursion. And I'll do that by calling the helper method and plugging in my values. Like so. And we're actually almost done. Really, the only other thing that needs to be done now is to accommodate the stuff that's happening inside of this while loop. We're going to do that as our repetitive recursion. Got to be a little bit careful though, right? In order to keep the recursion calling, we need, in order to keep the recursion going, we need to recursively call this method. The loop takes care of that for us, right? But in order for us to accomplish that here, we need to say square root helper and then plug in our old and our new values for x. Notice how I got away with doing this without really understanding how this code works at all. Don't care about the math. Not necessary to understand the math or how the math works. In order to solve problems like this, if you understand that recursion and iteration are two separate ways of performing repetition, then it's just a matter of including all the different parts. We do have one error. You can see that the original value of x is necessary as part of this computation. How do I fix that? Yeah. I'm sorry? A temporary variable. Xold is not always equal to x, though, is it? This is the original value of x. This is quite literally what we're trying to find the square root of. So I actually think we need 3 parameters here. I need the original value of x. I need... Is that true? Or were you... I'm thinking about what you said. Yeah, this has to be... I think we need this third parameter, though. Yeah, so I actually think we need a third parameter here to keep track of the original value of x the whole way through. There's one other error that I actually intentionally made here, and been waiting for somebody to call me on it. Eclipse is mad actually about both of these. Does anybody know why? Eclipse is mad about both of these methods. It's an error I would have expected you to maybe see before. I've got this listed as saying it's going to give me back a double. That's the result of the square root, right? How do I satisfy that? I need to return something. Where am I returning something? Right now, nowhere. Right now, nowhere. So to think about, what I need to return, this is my answer. So don't forget to stash the value that you're being given here. The way I had this written up here before, I was calling this method, it was giving me back the square root, and I was saying, all right, I'm just throwing it in the trash, ignoring it. Same thing down here. I also have to return something here. Eventually, this is going to hit my base case, and it will return what this square root helper is, but if I don't keep returning that value, then it's just going to get lost. It's just going to get thrown out on the way back up. Down here at the bottom, you can see we're taking the square root of 5 in 2 different ways. This should say square root r. These should be the same answer. This one's computing with the loop version of the method. This is my version that I just wrote, the recursive version. They should give me the same value if I did it properly. Oh, it's showing me, yeah, all the iterations. There we go. So here's the output for the first, and here's the output for my recursive method. It's actually printing out the exact same values along the way, how it's computing those values, and the square root of 5 is, it probably isn't exact, but it's definitely 2.2306. I mean, that's definitely square root of 5. 2.23606. 2.23606. Yeah, so I think eventually it'll diverge from the actual square root, but it's close. It's very close. Again, this is a tricky problem. I think what happened on the exam that I gave this problem on is that people got so hung up on figuring out what this actually does. I don't care. I don't care. I think what's important to understand is that this is what's being repeated. How is this being repeated, right? How can I use recursion to repeat that same stuff? You saw me just directly copy paste that code, right? I don't need to modify that code in order to use it recursively. Think of it as, you know, copying something from a while loop to a for loop, right? It's kind of the same general idea there, except I'm using recursion to do the iteration instead of a loop. Any questions about this problem? Yes? The while loop's up here. I'm not sure which. Of course. I'm recording all of this as well, so if you want to come back and take a look at my solution, it'll be posted right after class today, right after I get out of class today. Come take a look at the solution again. Any other questions on this problem before trying another one? You've asked me two of probably the hardest ones so far. Which I can understand, right? I understand why you would struggle on those and want to see some help, see me work through those problems. If there's no questions on this one, does anybody have another practice problem they'd like to see me work through? Or do I just need to pick one? Any problems? Yes? Question 10. This one? With recursion? Okay, sure. I can show how to do this one with recursion. Yeah, absolutely. It says you can use either, and it sounds like you're aware of that because you're specifically asking me to do recursion and not iteration here. Hopefully the iterative version is not too tricky to understand. Really, I'm trying to, this doesn't seem like a divide and conquer problem to me, right? So really what we need to try and figure out is, do we need a helper method or not? Is there anything that, you know, needs to be not repeated, or any additional parameters that we need to make this happen? I actually don't think that there is. I think this could probably be done pretty simply. This should probably be void as well. That's got to be a mistake, I think. It shouldn't return anything, should it? What does it say? It doesn't say it should return anything, does it? Oh, no, it does. It does. Well, no, it doesn't, actually. It doesn't. That's a mistake. That should just be void. But to get back to the task at hand, we'll say if n is equal to 0, we know that we're done, right? There's nothing else to do. Otherwise, we need to print out the string that we've been given. It's called text. And then we need to keep going. We need to call our recursive method again. But this time, we need to make sure that we are closer to our base case. So n is going to go down by 1. I think this is it. I honestly think this is it. If I run this, you'll see that, okay, so I got the repetitions correct, but it doesn't look exactly the same. Why? Because I used an ln here. I think if I take this out and just use print instead, there we go. Hi, 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 bye, 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 bye. Yeah. Here we are, recursive version. Couple interesting things to note here, right? One, if the return type is void, you can still use return. Return does two things for us, right? Two things for us. One thing that it does is it says, this is the answer. So if I say return x, then x is my answer, right? What's the other thing return does for us? Stops the method. So if I just see a return statement by itself, that just means the method is over. I'm done. Do not keep going. This method is done. Notice too that because the return type is void, I'm not returning this, right? Unlike the last example, I can't say return this because this isn't returning anything. This isn't going to give us anything, right? It's void. There's nothing here. So we're just saying continue. Move on to the next round. There's nothing to return. There's nothing to be passed up. And again, I think it's important to understand that like all recursive methods, this one will eventually hit the base case. And if I run this through the debugger, we can actually see how many times it's going to take for us to hit the base case. Surprise, surprise, if n is 5, it's going to take 1, 2, 3, 4, 5, and then 6 to hit that base case because I'm stopping at n is equal to 0. You actually could rewrite this if you wanted to stop at 1. What would I do if I stopped at 1 instead? I wouldn't return, but I would just do this again. Boop. So if I stop at 0, I would just say return. If I stop at 1, then I'll just print out the last one and stop. Right? I can run this again and show you. It still works. Still works. What is this called over here when I... oh, whoops. I meant to set that on the base case. What is this called over here when I can see all of the recursive calls on that I've gone through? I can see all the method calls I've gone through to get to my current spot. What's this called? Stack. That's good. The method call stack. And I work my way all the way down the base case, and then I go all the way back up to where I started from. The method that's always at the bottom of the stack is going to be this one, main. Because main is always the entry point of any program. Yes?
If you don't have a return on a void method, how does it know to move on?
How does it know to move on? Well, if I hit the end of the method, there's an implied return down here. So if you get to the end of the method, it's always going to return. Yep. You can't do this if the return type is anything other than void, because I have to tell you what the value is. So this only applies to void methods. Good question. Any other questions that I can address? Yeah. I'm sorry? It was just given to us down here. When we're writing this, it does not matter what the initial value of n is. Does that make sense? It does not matter what the initial value of n is. Either n is at a value where I need to stop, or n is at a value where I need to keep going. Those are my two options. So whether it's 7 or 12 or 5 does not matter to me when I'm writing the method, because if it's anything other than the position where I stop, then I'm going to do the same thing. I'm going to keep going. But to specifically answer your question, we provided these examples down here, which were intended to match these examples. Yeah. Be careful on the exam. This question might show up something like this, where I don't tell you what the parameters are supposed to be, and I leave that blank and expect you to fill it in. But I actually did tell you what the parameters should be, right? Look at this. Look at the way the method is used in the problem. This tells you directly that, oh yeah, there's a string followed by an integer. That must be what goes inside of these parentheses. Any other questions on this one? Yeah, what's up? Absolutely, I'd be happy to. We're going to do this one using iteration. I'll put an I on it for iteration. I think most people would probably just do it like this, even though this is maybe not exactly mirroring the recursive version. But yeah, I think that's it. If I switch these down at the bottom to use my new version of the method, yep. So now I can fit them both on the screen. Here's my iteration. Here's my recursion. This one ended up not being too bad recursively, but I hope you can see that, even then, the iterative version is very straightforward. If I tell you you can do it either way, don't make it any harder on yourself than you have to. Where are we going next? Anybody have another problem they'd like to see me? Yeah.
Can we do the Q11 code reading?
Code reading, Q11? Absolutely. Whoops, that's not the right one. Here we go. Code reading number 11. All right. So for these, you can obviously, run the code and see what it's gonna print out. If you're doing this studying, actually, I think the better thing to do, if you can't figure it out, right? If you can write out the answer on a sheet of paper, that's exactly what I'm hoping you're able to do. But if you're struggling with that, please use the debugger. That is quite literally what I am asking you to do on these kinds of problems, is pretend you're the debugger. Walk through this code step by step, one item at a time, and see what gets printed out. So, with that in mind, I'll set a breakpoint on the first part, right here, line 26, and we can step through the debugger and see exactly what's going to get printed out. So it's calling this method that's called left, and we can see that left takes in an integer array as well as an index. So when we step into this method, first thing we do is check to see if the index is greater than 0, which it is. If it is, then we'll print out whatever value appears at that index. So we can see that this array is 1, 3, 1. The value at index 1 is actually this one, right? Because the array started at 0. So I believe the first value I should see is 3, and there's my 3. My 3 coming out. And then it says return the value at the index -1. So index -1 would be 0, and the value that's at position 0 is the 1. And then that's going to get printed out because it's in this print statement right here. So the result, the return value of this method call is 1, and that 1 will also get printed out. So if I keep stepping through, there's my 3 and there's my 1. So that's the answer to part 1. Part 2 steps it up a bit. We've got a different array this time, right? And now we've got a loop that's feeding values into the array. So the first value that's getting, the first value that's getting fed into the method is 3. So 3 is getting plugged into the right method, and it says if x is greater than 0, which it is, 3 is greater than 0, then I need to return 3 mod 3. What is 3 mod 3? 0 plus 3 is still 3. So 3 is going to be my answer. But I'm not done yet. I have to now do the left method with this array, and x is currently 3. So if I step into here, we'll see that, yes, 3 is greater than 0, so I'm going to print out whatever value is at 3. That's the 1. And I'll return whatever is in front of that, which is the 7. That also is going to get printed out. So these two were from the first part. The second part, all we have right now are 1 and 7. Notice a few things, right? In my mind, I've already simplified this left method to print out whatever value's at this index and then print out the value that comes before it. At least if it's big enough, right? And so every time I go through this loop, I'm going to print out 2 values, one here and one here. So with that in mind, you can kind of figure out, all right, I'm going through this loop twice, right? Which means I should see 4 values printed out. The next time through the loop, I is 5. So if I think about what that means, 5 is still greater than 0. 5 mod 3 is 2 plus 3, that's 5. So I'm going to get 5 as the next value. And when I plug that into my array, I'll print out the value at address 5, which is 9, and the value at address 4, which is 3. So those are the next 2 values I expect to see come out. And there they are, 9 and 3. With the code reading problems especially, if you can simplify what these methods do in your brain so that you don't have to actually step through them every single time, that can help a lot. That can help save a lot of time. I've really genuinely, kind of internalized this as print out whatever value is at this position and then return whatever value is 1 before that. So I don't actually have to step through it one step at a time. I can just automatically do that anytime I see this. On the other hand, if I was doing this on a sheet of paper, I probably would be writing out the value of x on that sheet of paper just so that I know what it is, right? At every given moment, at every given time. For the last part of this problem, we're actually using yet another array, and this time we're stepping it up even further by combining these method calls inside of a while loop. So let's walk through this and see what happens. We're going to extract the item at position 2, which is the 7 right here, while we are not equal to 2. So I do see a 2. There's a 2 in this array. That's interesting. While we're not equal to 2, we're going to call this method twice. So if I plug in 7 mod 3 gets me 1, plus 3 gets me 4, right? So now it's 4, but then I'm going to take 4, I'm going to plug it in again. So 4 mod 3 is 1, plus 3 is, well, still 4 actually. So I get 4 out of here. I'm going to plug this value in here. So it wants to print out the value at position 4. Ooh, that subtraction is a little tricky sign there, huh? It's going to print out the value at position 4, which is the 3. And then the value that comes back is going to be the 1. So we wish to subtract 1 from x. That means that our value that gets printed here is not going to be 4, but 3. And again, I'm doing this in my head, but it's really getting to the point where even doing this in my head is stretching the limits of my brain. What I would really probably prefer to do is write out these values, right? First time through the loop, x goes from 7 to 4 to 4 to 3, right? So I'm going to write out the values of x every time it changes just to make sure I understand exactly what's going on. Let's do this for the next time through the loop. X is currently 3. If I plug 3 into this method call, we've actually already done that one. 3 mod 3 is 0 plus 3. That still gets me 3. Still gets me 3, right? So both of these are 3s still after the method calls. So then what happens here? I'm going to print the value at position 3, which is a 1. I'm going to return this value of 7. That's correct. Yeah, because that's at position 2. But we're subtracting it from here. I feel like I've gone off the rails somehow. Did I make a wrong turn? Or I'm actually gonna, I just want to see what the solution is to this one, because I feel like I skipped a step or made a wrong turn or some kind of a mistake. Part 1 and part 2 I'm happy with. It's just part 3 that I'm a little confused about. So for part 3, here we go. 3, 3, 3, 1, negative 4, negative 1, 2. Something's wrong with this problem. I think there must be a mistake on this part. And the reason I say that is because if x goes to negative 4, you would have to take the modulus of negative 4, and that's a weird thing to have you do. So I think this problem must have gotten copied wrong. I think there's a mistake in this problem from how it was on the exam. My guess is that that minus sign wasn't meant to be there, but I honestly don't know. Is that why you were asking about the problem? Because of this last part? I think you may have identified an issue with it, yeah. I think that minus sign was not meant to be there. Oh, but if I take it out, look what happens. What's going on? Infinite loop. Infinite loop. I actually still have this exam. I can go back and look and see. I mean, I'm not going to do it right now. I can go back and see what this problem, what was actually written, but I don't think this was it. This feels like a mistake to me. So sorry about that. My bad. For part 1 and part 2, though, those were legit. Those were good. Part 3's got some kind of an error in it. I will not ask you to do modulus of negative numbers on this exam or any exam. That is a promise I can make to you right now. Yeah, any questions on this one before we go to another? Question in the back. We are writing what it prints, period. I'm not writing what it returns unless what it returns gets printed. Yeah. So printing and returning are two different things, right? I think that's not what you were asking. I know that's not what you're asking, but that is a thing that students commonly get confused about. Printing something and returning something are two different things. Printing something is displaying it on the screen. And for the code reading problems, that is always what I'm looking for. I am looking for what gets displayed on the screen when I run this. A return value is simply passing data from one method to another. Can it be printed? Yes, absolutely I can print the return values. Do I have to print the return values? No, definitely do not have to print the return values. So do you need to write the return values on the code reading problems? That depends. Am I printing them? If I'm printing out the return values, then yes, I want to see them. If I'm not, then no, I don't. I don't want to see them. I only want to see what gets printed on these problems. Who's got another problem for me? Who's got another practice problem they'd like to see me work through? Yeah, up top.
Can you use question 12 in the writing?
Absolutely I can. Question 12. Okay, yeah, substitution method. I was hoping somebody would ask me to do a substitution method problem. This will almost certainly be on the exam. Almost definitely going to ask you to do substitution method. But really, again, when I ask you to do substitution method, what am I asking you to do? I'm asking you to pretend like you're the debugger. Walk through this code step by step. Show me the executions every single step of the way. Obviously, you won't have the debugger, so that's why you need to kind of get used to practicing these ahead of time. Let's go ahead and see if we can start writing these out. I'm going to write this out just as if I were writing this out on the exam. Okay, so first thing I'm going to do is I'm going to start with foo of 3, and I have to figure out where that's going to go based on the code. So I'm not here yet because n is 3, not 0. I am right here though, right? N is greater than 0, so that means that the foo of 3 is equal to this. 2 times foo of negative 3. Yeah.
Sorry, I mean, can you do the writing one? I mean,
Oh, I'm sorry. I clicked the wrong problem. My bad. I may come back and do this one though, because I am interested in substitution method. Sorry about that. My bad. All right. This is another recursive drawing problem. We actually saw one kind of similar to this already, but happy to do more of them. This one has a little bit of a trickier pattern. So I can see we start out with the squares. We're moving, it looks like in 2 directions this time. I'm going up and to the left, down and to the right. But also notice that the shapes change. And I believe the problem talks about that in more detail. Or does it? No, it doesn't. That's okay. We can see that for some given size, right, it switches to be circles instead of squares. What is that size? It's actually not given to us on this problem, so you're just going to have to make your best guess as to where that split point is going to be. But otherwise, it's going to follow the same process as with prior recursive drawing problems. The first thing that we need to do is draw something. But again, what we draw is based on this size. So if the size is bigger than 0.5, then I'm going to draw a square Otherwise, I'm going to draw a circle. We then have to have our base case, which our base case is going to be very similar to what it was in the prior coding problem that we did of this type. I'm just going to have to stop when my size gets to be too small. So, if the size is less than some arbitrarily small value, I'll just return. I'll just say I'm done. Otherwise, I have to keep going. And I have to figure out where my next position is going to be. If my center point is here, my next biggest square that I can see drawn is at the corner of this one, right? So I'm just going to go up left and bottom right. There's only two directions, top left and bottom right, that are being used here. So if I start with top left, that'll be R draw. The X center is going to go minus the size. The Y center is going to go plus the size. That's how I go up and to the left, right? Minus in the X direction, positive in the Y direction. And then the size itself is going to be divided by 2 based on what I'm looking at in the pictures, right? The actual size itself appears to be halved every time. This should get me the top left. Let's try this out and see. Oh, all circles. Okay. So that's way too big. I need to make this smaller. 0.5. That's probably too small now. Well, it does it though, right? Here's my squares. You can see that after a certain point it turns into circles. So if I can get it going in the bottom right direction as well, which is just going to be switching this to a plus, switching this to a minus. Try this again. Oh, beautiful. I think I nailed it. Pretty close anyway. It's looking very, very, very similar to the provided image. Yeah. I think that's good. So only two directions this time, top left and bottom right. The other tricky thing about this one is the fact that the shape switches. Notice that this doesn't have anything to do with the actual recursive calls though, or the base case, right? The shape that gets drawn is just a function of the size. If it's, bigger than a certain size, I draw squares. If it's smaller than a certain size, I draw circles. And just like the previous problem, if you were off a little bit in this number, I don't care. That's not what you're being graded on, right? More care about the structure of the code. In other words, when we grade this, we're not going to plug this in and compare the images side by side and make sure they look identical, right? We're going to check the structure of your code and make sure that the structure of the code is reasonable. I do want to actually go back and do the substitution method one because I think that one is important to show you a walkthrough of. But before I do that, are there any questions about this problem? I'm going to do the substitution method one next. Yeah?
How does the size change?
How does the size change? It changes with the recursive calls right here. So if the size is, starts out at 0.25, then the next time it's going to be divided in half. It'll be 0.125. Should this be over 2 or should it be over 3? Again, I'm not that nitpicky. Use your best judgment. Actually, a lot of times, I'm a little bit surprised, to be honest with you. A lot of times the problem will tell you exactly how to shrink the size. That's given to you. And I believe it'll even tell you this. Shapes drawn bigger than 0.05 are squares. Shapes drawn smaller than 0.05 are circles. Those in the past, I believe, have been part of the problem description. If they're not part of the problem description, you're not going to be graded on how accurate you are. You'll be graded on the structure of your code. All right, let's do that substitution method one that I started on accident. It is still a good one. A good one to work through. So, yes, substitution method. If it says do the substitution method of the following, then I'm going to start out by just writing that. and figuring out which branch I'm taking. So for the value of 3, I would end up here. And that means that I'm going to specify this. Notice that I went ahead and plugged in the value for n and stuck -3 here. And that tells us where we need to go next. We now need to figure out what this is going to do for a value of -3. So -3 doesn't hit this one. -3 doesn't hit this one. -3 is going to hit this one down here. So -3 is going to be foo of -2 plus 1. Everybody see how I got there? Hopefully. Okay, well now we need to figure out what this is. So foo of -2, still not the base case. We're still not positive, so I'm still down here. It's going to be foo of -1 plus 1. All right, now we have to do the -1. Still not the base case, still not positive, so we're still here, right? 0 plus 1. And now we're at the point where we've hit our base case. So if the input value is 0, we know what the answer is. The answer is 1. But we're not done yet. We are not done yet. We still have to do the second part of the substitution method, which is where the substitution method gets its name from. I'm going to take this value and I'm going to substitute it in for this on the previous line. So that previous line then becomes foo of -1 is equal to 1 plus 1, which is, of course, equal to 2. And now that I know what this is equivalent to, I can take this value of 2 and I can substitute it in on this line. And I'll keep that substitution process going. So foo of -2 is equal to 2 plus 1, which is equal to 3. Foo of -3 is equal to 3 plus 1, which is equal to 4. And then finally, we're actually at this one where we originally started. It's going to be equal to 2 times 4. So the result that we should get back is 8. This is exactly the same process that the computer follows when it's executing these recursive methods. In fact, highly encourage you to see this for yourself by setting a breakpoint at this line and stepping through the code. If I step in here, we'll see that, okay, here I am for n is equal to 3. I hit the first recursive statement. Now I see where I am at for -3, right? -2, -1, 0. Now I'm at the base case. Here I am at the base case. And then we work our way back up. The result for the value of n is equal to -1 is going to be 1 plus 1, which should be 2, and then 3, and then 4, and then finally multiply that by 2 to get us our 8. There's the 8. When you're faced with a problem like this on the assignment, I do expect to see working all the way down to that base case. And then, does it have to follow exactly the same format? No, it doesn't, but, be careful you don't skip any steps. Be careful you don't forget to compute on the way back up, because I'm also looking for that final answer, that final value of 8. And that's what gets computed when you perform the substitutions on the way back up, right? Any questions about substitution method? Okay. We've got 15 minutes left. I probably have time to go through at least one more code reading or writing problem if somebody's got one for me to do. Or I can just pick one. Not seeing any takers. So let's see. What's a good one for us to work on? Yeah, I'm going to do this one. I'm going to do this problem to wrap us up. We wish to create a method called getDiagonal it's going to take in a square array. The problem says that you have a square array, at least it should be a square array, and it's going to return the values on the diagonal. So for this problem that we see here, it might help if I format this a little bit differently to see the two-dimensional array more appropriately. I'm going to grab the 3, the 5, and the 2 and stick them into a one-dimensional array. That's what I want my method to return. So we need to write code that's going to pull the diagonal out of this array, this two-dimensional array, stick it into a one-dimensional array, and then return that value. Everybody with me? Okay. So first thing we're going to do is we're going to make an array to store our result. How big does this array need to be? We're assuming that this is square. The number of rows is equal to the number of columns. So how big does this need to be? It needs to be either the number of rows or the number of columns of the two-dimensional array, right? If it's 3 by 3, I know there'll be 3 values on the diagonal. If it's 4 by 4, I know there'll be 4 values on the diagonal, so on and so forth. So this will be a new array where the length of my two-dimensional array tells me how many items need to be in this array, correct? What is true about these diagonals? The row and the column are what on the diagonal? They're equal. They're equal. So you can actually use that to your advantage. There's a big shortcut you can take here. Some people see two-dimensional arrays and they say, all right, I need, my int I equals 0, blah, blah, blah. Whoa, 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 hey, calm down, Eclipse. That's not what I meant to do. They want to do this double array, or this double for loop structure because it's a two-dimensional array. I actually think that'll work here, but you're maybe adding some extra work. Maybe adding some extra work for yourself. You can do it in one loop. I might actually show you how to do it with one loop and 2 loops. They're both, for the purposes of correctness, they're both fine. I just think using 2 loops is overkill here. Let me show you what I mean. If I simply iterate across the rows, remember it's a square array. So the values that I'm looking for are the ones that have the same row number as column number. So even though it looks like I'm only iterating down the rows, I can actually use I for both the row and the column. That's how I know it's on the diagonal, right? So the first time through the loop I is 0, it's going to grab the value of position 0, 0. Next time through the loop I is 1, it's going to grab the value of position 1, 1. Next time through the loop I is 2, it's going to grab the position at 2, 2, and so on and so forth down the diagonal, right? We're almost done. Just missing one thing. What am I missing? A return. Missing a return statement. That's it. That'll do it. Pretty sure that'll do it. I actually didn't give you any code to test here, but that's okay. You could certainly write a little main method down here. To test this, you would just need to call your method. You would need to make the two-dimensional array first. So let me do that real quick. I can actually copy this. Oh yeah. Perfect. Let me just copy this without the stars. And then we need to call the method. Plugging in our two-dimensional array. And then finally, we need to print out our array, right? We good? You can see a happy diagonal get printed out when I run this? No. No, we are not. Can't print out arrays directly like this. Have to use a loop. So if I really want to see what this is, I need a loop here. This isn't part of the actual problem you were given. I'm just trying to verify that our solution works. It's called answer. There we go. Now, hopefully I'll see, hey, 3, 5, 2. That's the diagonal, 3, 5, 2. And if you want to, really test this, then we can plug in a 2 by 2 array, right? 2 rows and 2 columns, and it should still work. If I shrink the array down to a 2 by 2 and run it again, it should still work. Oh, I accidentally bracket. That's my bad. There we go. Once I create the 2D array properly, then it gives me the 3 and the 5, right? So it's always going to give me the diagonal regardless of the size of the array, as long as the array is square. For unsquare arrays, this gets to be a lot more tricky of a problem to do. Any questions about this one? If you did this with 2 loops, here's what I saw. I saw lots of people do this, actually. Oh, I'm in the wrong spot. Need to go up here. Yeah, if you wanted to really include 2 loops here, you could. But you're just adding extra work because now you have to do another additional check. If I is equal to j, right? Then, so I added all of that. Notice I have the same code more or less here, but why are you unhappy with me? Oh, I'm missing the last part of my loop, that's why. I'm trying to go too fast. That's what happens when I try to go too fast. I forget things. This will also work. I can run it and prove it to you. It's just more. This entire loop and if statement are unnecessary. Completely unnecessary. But it works, and I would give you full credit if you ended up giving me the solution. I have 8 minutes left. Does anybody have anything else they'd like to chat to me about? Any other problems? I don't know if I have enough time to go through a full coding problem. I have another review session right after this one, so if you want to review more coding problems, I'll probably do some of the same ones. I can't promise that I won't just do some of the same ones as before, but I got another class coming after this. I'm going to be reviewing more coding problems. You're welcome to stick around if you would like to study more, ask more questions, get more help in preparation for the exam. You're welcome to come up here, talk to me after class if you have questions. Otherwise, I'll see you on Thursday for the exam. Have a good week, everybody.